Welcome to the Mad Dog Institute of Metal Detecting and Hole Digging, located here in sunny Sacramento, California. I am Doug Kronemeyer. Today we're going to be comparing the detection performance of the Garrett AT Pro-Pointer and the Minelab Pro-Find 35. Here is the Garrett, sporting a nice orange color scheme, and Minelab with a nice black and yellow bumblebee color scheme. We'll be comparing both units' detection patterns for a silver dime. Additionally, we'll map the response of the Minelab Pro-Find to a 3-inch iron nail and see what the ferrous tone ID detection pattern actually is. The left side depicts the detection patterns of the two units for a silver dime. G is for Garrett and ML is for Minelab. The squares are 1/4 inch. The Minelab was set to level 5 sensitivity and the Garrett was set to level number 3. Both are max sensitivity settings for both pointers respectively. Green is when the coin is on edge and red when flat. The Minelab has a larger sensitivity pattern than the Garrett, except in the on edge area at approximately 1 inch from the head of the pointer, where they are almost identical. The Minelab's larger detection patterns should result in more efficient coin recoveries. The shape of all these detection patterns reveal that you can get a false sense that you are approaching a target as you dig deeper in the bottom of the hole, when in reality the target is in the sidewall and you are actually moving farther away from it, even though the frequency is increasing. Remember, the closer the target gets to the detector, the higher the response frequency once the target is within the detection envelope. In some areas, it only takes 1 inch to go from initial detection to max frequency. In other areas, it may take 2 inches to go from initial detection to maximum frequency. The right side shows the Garrett response to a silver 25-cent piece. No comparison was done with the Minelab for a 25-cent piece. I find more silver dimes than the do quarters, so I just saved myself some time. The blue line depicts the detection envelope for the Minelab unit for a 3-inch nail. Blue line 2 is for just iron detection. Blue line 1 shows the ferrous ID envelope. I am not sure how beneficial this feature is going to be. You can still be chasing a target only to discover it is iron after you get within about 1/2 inch on the nose and 3/4 inch on the side. It may save you some digging, but probably not much. Here are some hand pinpointing techniques. Marking your spot. After you have pinpointed with the main detector, I always mark the spot by twisting the end of my shovel over the desired spot. This keeps me from losing the location if I get distracted. Using the handheld pinpointer to get a sense of depth. Survey immediately around the suspected target position with the handheld to see if you get a signal. I survey with the head first. If no signal, then I search using the barrel of the pinpointer, as the barrel often results in greater depth. If I get a signal, I know that the target is probably less than 3 inches deep. I will dig a reduced diameter plug in this case. If no signal, then I will dig a plug with a larger diameter, fully expecting to have to go deep. Use handheld pinpointer to survey the surrounding surface. This technique will prevent you from falsely reading a nearby target near the surface while you are searching either the plug or hole contents for targets. If you get a signal during this survey, then select another area to place the plug in hole contacts. Cut and remove plug. Place the plug on the ground cloth. Next, check the plug for signals. Run handheld over the surfaces of the plug once the plug is removed. Search with both the head and barrel of the pinpointer. The barrel will often yield or alert when the head does not. See detection envelopes discussed earlier for the rationale. Remove target from plug if found. The next step is to check the hole for signals. Start with max sensitivity on the handheld. Reduce as necessary to acquire target. If you get too deep and you have not found a target, yet the pinpointer is alerting, one of two things can be happening. Number one, significant generalized iron particles in the soil, and you can just be digging all day long and keep getting a signal. Or two, more likely the target is in the sidewall. Again, see detection envelopes discussed earlier for the rationale of why this is occurring. Next step, recheck hole for signals with primary detector. You may have missed some targets, especially if they're in the sidewall. Next step, empty the contents on the ground cloth back into the hole. You want to make sure as much of the dirt gets back into the hole. The final step, replace the plug. Compress plug into the hole using foot or shovel blade as a mallet. If done properly, it is difficult to even know a hole was dug. Finally, dispose of your trash properly. Today's product comparison was limited primarily to the signal detection envelopes. However, the Minelab's plus or minus buttons, which we didn't really cover, combined with the larger detection patterns, make it a strong choice. Often when I'm in the bottom of a hole and the signal is equally strong everywhere in the bottom, I will reduce the sensitivity in order to get a better location. This is extremely easy with the Minelab, but the Garrett requires too many button pushes. One long push to get it in change mode, then 1 to 6 pushes to get it to the sensitivity level desired, and then another long push to get it back to the normal mode. And I may have to do that 3 times to go from level 3 to level 1 and then back to level 3 for the next hole. The Minelab plus or minus buttons are immediate and intuitive. One option I wish they both had, but do not, is an audio only mode. I have no need for the vibrate modes. As I only tested with the Garrett, other pinpointers may meet or exceed the detection envelope of the Minelab unit. Hope you enjoyed the video.